that one again and see what kind of reading you get when we measure the voltage across it and the current through it simultaneously. Let's move on to the second resistor in our series. This one had red, red, black, gold, brown. And I'm going to hold this on and I'll tell you what the multimeter gives me. And I'm getting a reading of, it's jumping around quite a bit. Let me hold that a little bit more firmly. 22.0, 22.0. And now I'll grab the third one. And I'll press that into here. And I'm getting a reading of 61.7 for the third one. And that was a blue, red, black, gold, brown. I'm going to go for the fourth one. The fourth one is an orange, orange, brown, gold. And it says overload, so it's more than 200. I'm going to go over to 2000. And we get 329 for the orange, orange, brown, gold. And the fifth one, this one is yellow, brown, black, and gold. And the multimeter says, I'm going to put it back to the 200 setting. Getting a reading of 48.40. Oh, now it's settled out to, so I'll say 48.2. 48.2. And lastly, if you want to do the sixth one, optional. This was the brown, black, 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 brown. I'm kind of curious what this one is going to give us. And I'm getting a reading of 100.5 for this sixth one. Okay, I'm going to pause it and set up the next step and with the next circuit. So in this next circuit, we're going to, we've read the code as best as we could, and for the first one, it was I first read it as gray, it was probably green. The other ones I think I probably did pretty well on, but we're going to test it now by putting it into a circuit, and we're going to measure what's the current through the circuit, and also at the same time, what is the voltage across the resistor. And if I know what the voltage is across a resistor, and I know how much current is going through the resistor, well, from our last activities in lab 6, we know that the ratio of the voltage to the current is the resistance. And so if you think of the graphs that we were making for lab 6, we saw that the ratio of voltage to current is the resistance. Well, we're measuring the voltage and we're measuring the current. So if I take the ratio of those two, this last column is, I'm just going to take these two values, divide them, find the ratio, and that's going to give me a clue as what the resistance is. Let me get that set up. We're ready to take data for our first resistor. This was what I thought was gray, but it's actually green, then brown, black. And I'm going to connect the circuit, and we're going to measure the current through the circuit. There's one pathway, and then I'm going to measure the voltage across just this resistor right here. So first, connect it, and the current is going to be 54 milliamps. That's 0.055 amps, and the current, I'm sorry, that was the current, and the voltage, I'm going to press this down and I'll say that the voltage is 2.7 volts, 2.7 volts. Right, this is the second resistor with the colors red, red, black, gold, brown. I'm going to connect it to the battery, and we're getting a reading of 105 milliamps. That's going to be then 0.106. So 0.106 amps, and the voltage is, let me get a good reading of this. I'm going to press these down. Okay, 2.4 volts. This is our third resistor. This third resistor value is blue, red, black, gold, brown. And the current is 46 milli. That's 46 thousandths. If we write that then for the amp, it's going to be 0.046 amps. 0.046. And the voltage across our resistor is going to be, oh my goodness, that's interesting. I'm getting 2.8, but if I push on it a little bit, yeah, still 2.8 volts. I wonder why that went up higher. It makes me a little suspicious about the first two readings that said 2.4 volts. This is our fourth resistor. It's the orange, brown, gold. And we're getting a reading of about 9 milliamps. That's 9 thousandths, or 0.009, 9 in the thousandths place. And let's take a reading. I'd be interested to see what this one is now. 2.9, actually 2.96. So let's round that to 3.0. It's fluctuating, right? 2.9 or 3.0 volts for that resistor. This is the fifth resistor. This resistor had yellow, brown, black, gold. I'm gonna hook it up, and we're measuring a current of 56 milliamps, so that's going to be 0.056 amps. And the voltage across this one is 2.68, so 2.7 volts across this resistor, 2.7. And our last resistor, for those of you who wanted extra practice, it's a brown, black, 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 brown. Getting a reading of 29 thousandths of an amp, 29 milliamps, 0.029 amps. And our multimeter gives us a reading of, let's jump around a little bit too much, 2.9 volts. So your goal now is to take that data, and you have to do calculations for the tolerance, knowing what the tolerance is. If it's 5% or 1%, take 5% or 1% from the resistance, that's from the color code. Then we're also looking at the measured values when we just use the multimeter by itself. This most recent data, we measured the voltage across each resistor while there was current going through that resistor. If we take the ratio of the two, that's going to give us this last column. So perform those calculations. That will help you then answer questions 1.5 and 1.6.